Welcome to the Trend Detection Podcast, powered by Siemens. And now your host, Niall Sullivan.
Hello, and welcome to this episode of the Trend Detection Podcast. I'm really pleased to have a very special guest today, an external guest, so outside of Siemens. We've got Evan from InfluxData, who's joining us today. We're going to be talking about, I was really pleased that we were able to do that today. And we're going to look at its role in creating intelligent industrial IoT systems. But I guess before we get started, Evan, would you like to sort of introduce yourself and InfluxData as well?
Sure.
That'd be great.
I'm Evan Kaplan. I'm the CEO of InfluxData. I have been with the company since we were pre-revenue. So I joined in 2016. We're the leader in a space called time series data, which is really oriented from the industrial IoT world. The way a lot of people think about it is industrial historians, things like that, things that collect sensor data and measurements at high velocity and high scale. InfluxData, we're about 200 people. We have 1.1 million people who use our database every single day because it's open source. And so many people use it. Everybody from the largest industrial corporations to home users and hobbyists. Within the industrial IoT space, honored to count Siemens as a fairly significant customer, Honeywell, PTC, and a variety of other Schneider Electric, other industrial concerns. But our business goes beyond industrial IoT to the broader IoT market.
Excellent. And I guess just to start with as well, because you've been working with Senseye for a long, or Senseye Predictive Maintenance as we are now, but you've been working closely with the team for quite a while now, haven't you?
Yeah, my team has been working pretty close with Senseye. They were an early user of our cloud native product. And you could probably describe what Senseye is eventually doing with the data, but it's largely around collecting sensor data and driving predictive maintenance models for people to drive more efficient maintenance.
No, that's great. And yeah, really pleased to have you on, Evan. So yes, let's dive straight into it really. So can we just start with, like, I guess the baseline. So explaining to the audience what industrial IoT is, and why is it significant today, like more than ever, let's say, but I'll let you sort of just, what's the landscape looking like at the moment?
It starts with the broader trend of landscapes of everything from systems and AI and that, and then it drops down to IoT in general, and then it drops down to industrial IoT. So we'll start at the highest level. I think we are clearly dealing in a world where all the systems we're designing and building, we want to grow in increasing intelligence. And what does intelligence mean relative to these systems is, first they mean they're self-correcting, and eventually they mean they're self-healing, and eventually means they're learning systems, whatever they are. The canonical example is a self-driving car, but there are all sorts of systems that sort of fit that model. And you coming from predictive maintenance really would understand that quite well, is all these systems want to grow in intelligence. That's one dynamic that's super important. The second is they want to use that intelligence and operate that intelligence in near real time. And so increasingly, you want that intelligence delivered in real time. And again, we come back to the canonical examples of self-driving cars, but the same is true in industrial systems. So if you take those two broad trends overall, right, and you think about what's going on in IoT generally, and apply it, you start coming up with, some of the businesses that Senseye's developed. But start with, you come up with the idea that increasingly the physical world is being more sensified. And that's, in factories, that's every piece of machine, even outdated machine that didn't have sensors before, have PLCs, have a variety of different stuff. in oil and gas and processing, the same thing. But it's obviously broader to our cars, our homes, our healthcares, our cities. Physical sensors are everywhere, and the ability to pull and read that data becomes incredibly important. Those sensors speak time series. They fundamentally speak time series, whatever they're doing. It could be pressure, it could be temperature, it could be light, it could be humidity, it could be electrical impulse, it could be anything, but they speak time series, which means they're recording what are happening in the world, and they're doing that on a time-based interval. High resolution time series is down to nanoseconds, where we have some customers doing nanosecond measurements. And lower resolution could be every minute, every 30 seconds, that sort of stuff. But in this world of smarter and more intelligent systems, you're trying to feed what is a big pipeline. And predictive maintenance is a good example of it, right? What you're trying to do is collect as much high resolution data as you can reasonably and economically process, right? That describes the world that the system is operating in. And then you're using training models or AI to build intelligence around that. And then you're implementing that into a control system. And so you've got a car, the tires are relatively low at inflation. The back tire is at 20 PSI, the front tire is at 40 PSI. Your system comes and it alerts you and says you need to change the tire, or you need a road, or you need to inflate and all that. That's a very crude thing, right? But you're taking measurements on the tire regularly and that sort of stuff. So you can imagine in the industrial world, I've got a hydraulic press, for instance, and it's creating X pounds of pressure at a regular basis. That varies by 0.02 pounds over a 2-year period. It starts to vary significantly. Predictive maintenance says you better change these following parts. All of that is coming because of rich sensor data. Now, if you can imagine, it's a vector that has to be monitored really, really closely. The temperature of the system, the dynamics of the system, a variety of different stuff. You can imagine maybe 1,000 metrics a second pouring in, and some of our customers are hundreds of millions of metrics a second. Now you can really describe what's happening in the real world. If you can do that, then your ability to build a self-correcting, then a self-healing, then a self-learning system becomes more and more powerful. Which means, and I'm sorry for the long answer, you bring that to industrial IoT, and that's the grail, right? Systems that operate over long periods of time in increasingly intelligent manner without human intervention, right? That's where, and operating in real time, making real-time adjustments to things, to environments, and that sort of stuff. That drives efficiency, that drives productivity, that drives the economy. So that's the long answer to your short question. Sorry.
No, that's all right. No, we love long answers on the podcast. The less I'm speaking, probably the better, is what I always say. But if we take it back just to time series data to start with, like in terms of a definition of it, for people who may not know it, they might have heard the term. And what role does it play? In everything you just said there. I mean, what's its role?
Yeah. So let's start with its definition. So it's a database that's oriented, that's specifically oriented towards time index activity, right? And so the primary index that you're going to look at, not the only index, but is going to be time. What happened, in order to figure out what could happen or what's going to happen, right? But you have to start with what happened. And so time series data is really excellent at what happened. And so, and the higher resolution, the more you know what happened along multiple variables. Could be pressure, temperature, humidity, light, environment, all at the same time, that kind of thing. So that's sort of what time series is. And remind me the second part of your question. Sorry.
Yeah, it's just why is it crucial in sort of a lot of it you described in your previous answer, but why is it sort of critical to all of those great benefits you mentioned?
Well, it's I'll come to why it's critical, but the history is it's been, as long as we've had data, maybe you could argue as long as we have Abacus, as long as we've had observing the stars, we've done time series data, right? this time the sun was at this position, that sort of stuff. So it's historically, I think what's new right now, or the last 5-7 years, is that generally you take a general purpose database and you collect time series data in a general purpose database. And this was true for all kinds of data. So search had its own category, graph had its own category, document has its own category. Now time series has its own category, because what's happening is, if you understand the nature of the data, your ability to handle it really efficiently at scale changes. And so we pioneered, Paul Dix, my partner and our founder, pioneered this notion of a modern time series database. And he did it by building one and delivering it in the open source, which is why there are so many open source users of Influx today.
And that's an interesting. So openness is, I guess, something we talk about with Senseye Predictive Maintenance as well. So, open platform can integrate. Is that sort of the reasoning behind that? So, it's a flexible product.
There's openness along two things, two vectors, right? So openness in terms of, does it integrate well with other systems? The answer is yes. But there's openness in terms of the source code's open for the base stuff. It's an open source platform. Our view is that almost all the powerful databases that are being used now for new systems today are based on open source. In the world of industrial IoT, which is a pretty conservative world because you're dealing with often very big capital equipment, that change is happening now. It's a slow change, right? But that change so for instance, in tech, and everything from Google to Microsoft to Airbnb, right? That's happened very fast, right? Is like, as you'd expect, the change vectors, the change timeframes are different. And so there's openness in terms of that openness that people are really interested in, is this open source database. The ability to feel like you're not trapped by a vendor. So if you look at industrial IoT, you've got a history of I don't want to say trapped, but you've got a history of historians, OSI Pi, Aspen Technology, Wonderware, that are expensive, that are closed systems. They probably integrate okay with other things, but you're tied to the vendor. You never have another option, that sort of stuff. What's happening in industrial IoT, and I think this is a really important dynamic, is IT, and even more importantly, developers, are playing a much larger role than OT, than it used to be, where you'd buy software and you build a manufacturing execution system, or you buy an industrial historian, you buy it from a vendor, and you were locked into that for sometimes 30 years because the equipment's old. More increasingly, we're working with developers in industrial systems who are building their own, who aren't depending always on the large manufacturers. They're integrating components from them, like you guys, Senseye, and they're building their own systems. And so we call that developer-driven IIoT, right? In which real developers are doing work to build systems that aren't dependent on specific manufacturers. I think it's an interesting dynamic. It's kind of a democratization, if you will.
Yeah, no, exactly. Yeah, that makes complete sense. Build it. But I think we've had this, or I've recorded a podcast on this topic, this build versus buy debate. Is there sort of limitations with that approach as well? I get that you can build something that's more open, but does the build side have limitations?
Yeah, for sure. There's no question. There's always a build versus buy, and there are limitations associated with that dynamic. I think the thing that's changing is how much cheaper and cheaper and cheaper and more efficient it is to build. And it used to be really, really expensive. You'd have to buy an Oracle database. You'd have to buy, you'd have to a bunch of IDE environments. You'd have to do a bunch of stuff. You'd have to do integration. You have to get manufacturers to unlock their APIs. Like, it just used to be a really, really ugly mess to do that sort of stuff. But over time, it's getting way, way cheaper, and it's starting to become an imperative. And it's starting to become an imperative largely driven by, this really strong and important interest in AI, in which, your data, you need to be able to process it. You need to be able to have deep understanding of your systems if you want to be effective. There'll always be people who build and buy, and it's usually a combination of both. But I'm just saying, in the industrial world, buy has been the dynamic for years and years and years, and we're seeing much more builders.
And so is it a case of being a balance between the two? So it's not like build is bad and buy is great, but it's more of looking at a combination between the two sides to build, a really joined up solution.
I think it's always sort of a combination. You're always going to build, for instance, even if you're using Influx, if you want to use the commercial versions that are hardier and scale faster and longer, you're going to buy that. There are going to be specific AI stuff that's oriented towards industrial IoT. There's going to be people who offer. So I always think it's a combination. And perhaps the right word is assembly. You're assembling a wide variety of solutions as opposed to dependency on one vendor, the way it often would play out in the past.
And I guess, with that multiple vendors and build versus buy, there's going to be lots of different data sources. So maybe we could talk about sort of the challenges of sort of it, about, I guess, acquiring those data sources through sensors and other means, but also integrating those together to then be able to use that for predictive maintenance or other use cases. What are the sort of challenges around that?
Yeah, it's meaningful. It's interesting, and there are big changes in that ecosystem too. So for instance, you collect our time series data, and while it has metadata, you may want to enrich it more with more and more data and asset information and things like that. And so you generally going to want to do that somewhere. Sometimes it's within our database, but often it's within what a lot of manufacturers have now is increasingly these data warehouses or lake houses, which are a big part. And what happens is there you're taking in the structured operational data and some of the unstructured data, you're combining them, and you're building your intelligence at that layer. But then you're applying it to the systems. And so you take the data that's coming, the rich data that's coming from Influx, you may combine it with some other data, you build a training model. And I don't know exactly how Senseye does, but probably something like this. And then you spit out a degree of intelligence, and then you incorporate that intelligence into the operational system, which is often involved. Influx is often involved in that because we see the real-time data flows of the sensors. And then you operate your system that way. Is you push the intelligence out to the edge, but you do the intelligence building up in the training models and the inference up in the cloud, up in a lake house or in a big data warehouse that you may have on-prem, whatever it is. That we're seeing a general architectural shift, operational databases, and then these lake houses to store and combine and build your intelligence. Does that make sense?
No, it does. It does. And I wonder with all this data collection, because I've been at many events over the years where I've spoken to many different companies and people who collect, who have been, collect lots of data, have a lot of the data ready to go, but they just don't know what that next sort of step is in the journey. So they've got data, and is that something you experience as well? The data collection's a thing, but it's actually the what to do next is always, some companies just are unsure at this stage of what's the next step from there.
Yeah, I think that's. I think I think that's generally true. One is maybe they don't have the right people or the headcount or that sort of stuff. And I assume, again, I'm not going to pretend to be an expert on Senseye, but that's where you come in. Is you take the raw data that's coming out of the system from Influx and you help them figure out predictive maintenance models with that. There's no doubt they need help. And so sometimes systems help, sometimes it's people help that does it. But but a lot of times they are just collecting the data so that they can eventually go back and look. So a number of our customers are large regulated industries, energy specifically, and they have to keep data for 10 years. And so they're meeting a regulation requirement, but now they have this tremendous set of data. They can look back 10 years of the way certain systems performed interventions. And when AI comes into play, that's a really rich data set to work with. Now it's kind of expensive to keep 10 years of data, but they have to anyway.
And you mentioned there that you work with sort of regulated industries. So with all this data, let's say not floating around, but flowing between systems and from different machines and other things. Is there, how are sort of security sort of concerns addressed on that side? Because data is obviously a hot topic in that area.
Yeah, I think obviously within our platform, we're very specific to who can access the data, how they can access, and what data they can access. That's kind of all we can do. Once they integrate it into lake houses or other systems or that sort of stuff, yeah, I mean, I think, even in these regulated industries, they're trying to adhere to a bunch of standards that's around data protection. So our role is relatively straightforward. Who can access the data? Is the actual stream of data that's being collected, does that have integrity so it can't be interrupted? That's sort of our role. The larger systems role is probably much more complex.
No, I know, of course as well. And often sort of the challenges faced, and again, we can relate it back to what we're doing with Senseye Predictive Maintenance, is the challenge is often at scale. So I'm sort of wondering how a sort of time series data can help, overcome challenges at scale rather than, a small number of machines, for example. How can it be
Yeah,
set up that way?
yeah, that's the strength of it. Yeah, I mean, that's really the strength of it. When you can get specialized around the time series data and the sensor data specifically, you can be super efficient. So our ability to ingest is pretty amazing. Ingest huge amounts of data at a time. So you can imagine large systems that have thousands and thousands of windmill sensors or something like that, and you're collecting at a period of less than a half a second or 50 milliseconds, right? The level of ingest has to be elite. It just has to be a normal database would not handle that kind of ingest. First of all, the ability to pull the data in from the real world. The second is often that data has to be high cardinality, which means that not only am I pulling in a measurement, but I may be describing the measurement with 8 or 9 tags that say it was this time of day, but it was this kind of light, it was this kind of pressure. That's high resolution data. And when you start putting high resolution data in a database, it can really, it's something Kurz calls you have cardinality. There's too much cardinality, too many different vectors. So time series databases, the elite ones, are designed so that they can handle that kind of cardinality without being choked. Most databases would be choked off with that kind of variation, particularly because they have to perform in real time the way time series do. The third is you often don't keep that data around in its original form. So if you can imagine nanosecond sampling, you're constantly downsampling, you're constantly summarizing. So you have to be able to summarize the data and evict data very fast. So what you end up is a highly specialized platform really built for sensor data that can drive companies like yours, right? That can drive you to build intelligence around that data.
Yeah, no, absolutely. And so we can presume companies. We talked just then about how processing the data, how important that is, for real time insights. But maybe Evan, we could talk a little bit about some of the use cases. I know predictive maintenance being one, but what are the more common use cases that you sort of talk about with your customers for utilizing this time series data?
So I think you have to think about it in two broad categories. One is real-time monitoring. The other is real-time control, and they're related. So real-time monitoring is virtually any signal that's coming out of a sensor, right? I want to look at it. I look at a dashboard. I maybe even put an alert up that says page a person if the system gets out to this Y, all that sort of stuff, right? So that's the biggest part of our business today is real-time monitoring of everything. A lot of satellite applications, a lot of aerospace applications, a lot of energy applications, a lot of industrial applications, even a lot of software applications that we're monitoring, APIs, network telemetry, things like that. So lots of real-time monitoring is the primary and core use case, right? So that people can see dashboards, people can do. The second is real-time control, which is the ability to look into the data stream and as things change, provide an alert to a control system and act on it. So not just a passive look at a dashboard, but alert to a system that has control. And so I don't know how the Senseye works, but lots of customers have control loops. You get something out of Influx that reads it. They've written some software that issues a commands based on those values. That alert then spins up another compute instance, or actually sends a truck roll or does something. That I view as a control system. And so this is really broadly applicable. Industrial is one space, and it's a really great space because obviously manufacturing can be reasonably contained. But it applies to IoT generally. It applies to my Apple Watch. It applies to my car. It applies to my house and the sensors and that sort of stuff. It's the same idea, but applied, which is it's the same data type. We're reading sensor data and we're making sense of it. We're either monitoring or we're monitoring and controlling.
Yeah, that's interesting because I guess day to day we don't think about things like that. But I guess what the watch I'm wearing, monitoring. I was going to mention the brand, but you probably guessed the brand that's monitors my heart rate and everything else. So does that make it more relatable? Because I guess I don't think of it like that, but maybe other people don't think about the fact that we're doing similar things in our everyday lives, not just in industrial settings or manufacturing settings.
Yeah, it's kind of profoundly elemental, to be honest with you. And so hopefully that makes it relatable when I have to describe it to folks. I mean, if you just think about the human experience and the first people who ever looked up at the stars and tried to figure out why the sun was in the sky at this at this thing, they were doing time series compute, right? They were doing it in their brains. I have the same watch, I assume, some brand, and and it doesn't it's not changing anything for me. So it's a dashboard basically, but it will send me, it's supposedly supposed to send me alert if I have an arrhythmia, or it's supposed to, if I set it up, it'll have alerts to say if my heart rate's above this level or that level, right? That is, I have a bunch of these, and these guys are our customers, the Nest thermostats in my house. And they send me alert when when they're to adjust the temperature, or they self-adjust, right, based on some free thing is saying I want it to be 70 degrees when I go to sleep or something. Sorry, I'm speaking Fahrenheit.
No,
It'll have to be 70 degrees Celsius when I go to sleep.
No, exactly. It's hard to translate that in my head, but I'll Google that later. I think to understand. So I guess one thing we haven't sort of touched upon in great detail, or a little bit, but in terms of like AI, machine learning, and is that coming up more and more in conversations, like use cases?
Sure.
I imagine you'll be saying yes, but is the demand's very high at the moment?
Yeah, I mean, I just came back from a trip to Europe and met with a bunch of industrial companies, brand name companies, including yours, and not the Senseye division, and almost everybody is grappling with, okay, how are we going to manufacture intelligence? And literally, that's the terminology: is how are we going to manufacture intelligence to make things more efficient, more productive? Now the tools are starting to be available, whether they're LLMs or sophisticated machine learning. And where we look at it is that intelligence manufacture is like a refinery. We at Influx, what we're going to be really, really good at is collecting that data, pulling the oil out of the ground, right? Organizing it so it can be refined in intelligence, and then going to be really good at basically helping build the control loops so that the system gets better and better. Collecting, organizing, controlling. That's where we're going to be. Where the companies are building their intelligence and doing all that, that is happening in the refinery. That's happening where they're collecting all the data, looking at it, doesn't make sense, right? Now we turn that into a model. I mean, I assume that's exactly what Senseye is doing. Collecting all of it, turn it into a model, make it machine learning at its best.
Yeah, no, absolutely. And now we've of course got the layer of an extra layer of generative AI as well. So maybe I'm sure that's come up in a lot of your conversations as well, Evan, as well.
Yeah, you're seeing an interesting combination of both machine learning and generative AI in this area. Yeah, and so I think we're really at an incredible blooming I mean, in my life, I'm old enough to have lived through a number of these these revolutions. Most substantive, obviously, is the internet connecting all of us, but this is even more substantive to me. This is the stuff that's happening is pretty amazing to me. Just as a consumer and interested in technology, information, gadgets, it's already changed the way I behave every day.
Yeah. Okay. Yeah. In ways we couldn't have imagined. So I guess it's only natural it's going to be in the more industrial settings as well. A lot of these use cases are going to be applied.
It's going to be fascinating. I mean, unassisted manufacturing floors. I was at a company a couple of weeks ago in Europe, um, manufacturing batteries, and it was almost a completely hands-off manufacturing operation. I was so impressed. I got to see it. I got to see the robots moving. I got to see. I was like, okay, this felt more real to me than it ever felt before.
And that's interesting. So if we touch on that subject a bit more, so something you saw there, but are there any examples? I'm sure there are lots of examples of customers, that are doing some really interesting, things with time series data. You're able to share maybe one or two examples of that?
Yeah, sure. One that's really close to me um, because I use the product myself. I mentioned Nest already, so that's always interesting, right? I don't, I assume you know what Nest, but we also have there's a company in Europe called Tato that does similar things. That also a customer. There are a number of these self-controlling thermostats. Pretty interesting. But I think probably the most interesting to me because I also use the product is Tesla's energy systems. So I live in California, and I have this new thing called solar roof tiles. So they're not solar panels, but they're literally like solar shingles. And so you assemble. I needed a new roof, and so I had this. I was on a wait list, and I had this installed. There's shingles that generate, solar energy, so you don't have to have the big, ugly panels on your roof. And along with that, I have 3 Tesla Powerwall batteries to store the energy in case of an outage, because we have those because of fires and different stuff here. And those Tesla Power, we've been working with Tesla for probably 6 years now. They've built a system that basically collects all the information coming from the solar inverters and the stuff that's stored in the battery, and it reports out to an app on my phone that I look at. I look at it a couple of times a week because now it works really, really well, and I can see how much power I've generated, how much I've used, how much goes to the grid. And then they've done this phenomenal stuff, which is they're allowing me to using Influx to measure all of this sort of stuff when there is sort of super high temperatures and the grid is really tested here. They're allowing me to sell my power back at an inflated price. And so all of a sudden, first of all, I'm net neutral to the grid. So I'm net putting way more back onto the grid than I'm using. And secondly, I can spot sell. All of a sudden, I'm like a little utility at my house. And none of that happens without being able to instrument literally every second how much power, how many kilowatts, how much usage on those batteries, how much is coming off of the inverter, how much per day I'm using. And I can see that all in my app. So in some crazy way, and this is, I realize I like experimenting with this kind of technology. I'm a freaking utility. So I find that stuff fascinating. But by the way, I've watched them develop this. I watched them first get the app running so they could just see passively how it worked. I watched them as they figured out how you'd monitor how much was going back to the grid. And then I watched them as they built this spot selling system, which the utilities wanted because they don't want to build capacity for something that's a spike event if they can draw it from their customers. So an interesting dynamic.
Yeah, that is interesting. An interesting reuse of energy. I've never heard anything like that before. That's That's really cool. Basically,
Yeah, I think it is really
yeah.
cool. It's happening, more and more in the U.S. We're able to do this. Because you also have to cross regulatory boundaries and technology boundaries. I was super impressed with these guys built. There's an interview online where I interviewed the designer of the system. If you ever want to look at it, he's quite impressive.
Yeah, no, maybe we can put that in the show notes if we can get a link to that. That'd be really interesting as a follow on to the conversation too. But and so I guess in terms of like looking into the future a little bit, are you seeing what sort of emerging trends are you seeing in the market, Evan, at the moment, or technologies that are sort of going to push companies
Yeah,
forward?
I think because we're talking about industrial IoT, I think the thing that I was most impressed with in my recent sort of customer visits is just how much people were really embracing or contending with the connected factory, where all their devices and systems are increasingly connected. Like there seems to be in most of the large players, the whole teams that are oriented around connected equipment. And then secondly, how they were thinking about using that data, the intelligence orientation. That stuff seems to be really, really amped up right now. Both the data architecture to support that with things like Influx and replacing older legacy systems, but also just the need for this expertise around machine learning and AI, the real desire to go after that hard. So that feels different than it would have felt 2 years ago to me. Felt like everybody could kind of take their time a little bit, and now it feels like there's a sense of urgency that I'm pleased to see.
Yeah. And is that urgency sort of to just keep up in the market generally, keep up with competitors, or competitive advantage? What are the reasons
Yeah,
behind that? Do you
so
think?
it's a couple of things. So it's so elemental, right? The more efficient the factory, the more efficient the industrial concern, the more competitive you are in the market, right? It's just really, really that. Unless you've got some specific patent portfolio that's protecting your interests, right? Your efficiency is what's going to drive your margins. So that's really, really elemental. But there are a couple of world trends. The transition to a better carbon utilization or carbon neutral grid, energy production, transportation, all that. The other is in the U.S., particularly the nearshoring, the wanting to bring manufacturing capability back to North America largely from China, and so those things are driving new industrial concerns and interest. And I think the same. I don't know as well. Maybe you could opine, but I think some of that same dynamic is happening in Europe. And so, maybe I don't want to call it some challenging dynamics around globalization are making people want to nearshore more, which means more factories are getting built and more. In the U.S., we had this $1 trillion bill passed that was for energy and nearshoring and those sorts of things and chip manufacture. So, and I think those things are all drivers here.
Yeah, and that's something we actually didn't sort of go into as well, is that topic of sustainability. Obviously with your Tesla example, you did that you can see where that fits in, but there, sustainability is obviously going to be a major use case around data and time series data.
Huge, gigantic. I mean, it's such a broad term, but just in general, energy efficiency. We're coming up to this AI. One of our customers is probably the largest data center provider in the world, or one of the largest. And so much of what they do is heating and cooling of systems and providing energy to systems that do all this compute work. And we know that that's scheduled to go through the roof. And so their relative efficiency, how much they could dial those in, is really, really important to sustainability. I'm glad you brought it up. Yeah, it plays well to where we are sitting, because there aren't off-the-shelf systems for doing all these things. Most people like Tesla have to design them if they want to be good.
Yeah, well, exactly. Or you look at use cases like predictive maintenance or Senseye in this case, because we don't say we're a sustainability tool. That would be incorrect. But some of the business outcomes lend itself to sustainability. Better machines working more
100%.
efficiently, less spare parts, usage and that kind of thing.
It's 100%. If I can capture that, if I can capture a system before it fails either catastrophically or problematically, I'm dramatically improving the relative efficiency, and that eventually, whether it's the cost to manufacture new components or whether it's the cost to do an adjustment in the field versus a truck roll, it all has sustainability implications.
And I guess just a theme from you, Evan, as we're talking, from a predictive maintenance perspective, are you seeing a lot more or increasing demand for predictive maintenance solutions, or any changes in the market over the past few years? Is that the sort of market's maturing somewhat?
In some level, a lot of that stuff happens above us, if you will, in the way that Senseye uses InfluxData. Like, unless you're willing to share all your details, I don't always know exactly what you're using us for. So in some ways, it's happening above us. But there's no question in my mind that predictive maintenance is a huge industry. At every sort of in every sort of sector you can imagine. Right? Everything from compute to big physical systems. Predictive maintenance is incredibly critical. And it's probably the first application of AI, right? Because the problem space is understood reasonably well, because you've been doing stuff like this manually for long periods of time.
Yeah, no, exactly. And it's that concept I mentioned before about collecting data and looking for something to do it. So if you can use AI, machine learning, and Gen AI, as we're in that world now, to make use of your investments, and especially existing investments as well, so you don't have to invest in lots of new sensors necessarily, because there'll be a lot of gold there already, you'd hope, that can be used.
But the sensors, yeah, that's true. And the sensors themselves are so relatively cheap. That's not the driver in the cost system. The driver is the capital equipment that the sensors sit in, the robotics, all the variety of,
the stuff that I'm going to call it the fancy stuff from a little outsider perspective, but robots look cool, right? So I'm sure they cost as well.
Yeah, I have a bet with my partner Paul that about what the time frame is when we have a meaningful robot in our house doing our day-to-day cleaning and that sort of stuff. And he says something like 10 years. That we'll have an affordable robot in our house that can do most of the cleaning that happens today.
Yeah, it actually reminds me of something my wife shared with me. It was a quote that basically said that it'd be great if AI could solve things like like washing the dishes and what I term as real world everyday problems like that. That'd be maybe that's the dream for some outside of industrial settings.
Don't you think it's kind of an inevitability? Like, I don't know when, but if you had asked me, so I was involved with the original licensing of browsers in 1996. So the original University of Illinois. And so I go back. So I was there. I was watching closely what was happening as as the internet, as we understand it, was taking off for general use. And if you had asked me to ideate like what would happen 10 years forward in that world, that there would be a Facebook, that there would be big social media, that I'd have a device on my phone that can control my sprinkler system at home, or this sorts of stuff. And I just would not have had the imagination to think about that sort of stuff. And so I'm humbled by what the world would look like even in 10 years.
No, absolutely. We have no idea what's to come. If anything, if you keep looking back 10 years, the developments have just been amazing. So there's a lot to come, I'd say. So I guess as we're sort of coming towards the end of the session, so what we usually do, and we guess, is sort of just to summarise a little bit, and maybe even offer some advice. I guess in your case, Evan, I guess it's advice, maybe 3 bits of advice for people sort of looking to invest in time series data and data collection, and where should they start on that journey? What's your sort of
Yeah,
guidance on that?
I think they have to start with the why. Right? Start with the why. What am I trying to make happen? How am I trying to make a difference? I'm running a factory. I'm a machine manufacturer. I'm whatever. And so my first orientation is make sure my devices are connected. And you'd be surprised how many devices are not connected. Right? Make sure that they can spit off their states, and by means of that, they're instrumented so that you can know what the devices are doing. Right? Make sure that that you can begin funding a team that's capable of doing things that are of value with that data, whether that's predictive maintenance, whether it's even more advanced forms of intelligence. And you start with the instrumentation. And for us, Influx is free. You can use the open source. You can build stuff on it almost right away, right? So start with the instrumentation and move up from there. That would be really, really simple. Start with make sure that you're instrumented, make sure that you're collecting the data, begin to look for patterns in the data, and begin to think about how you can make things more efficient. It's a really fundamental kind of motion, but everything has to be connected. There has to be sensors, and you have to be able to collect the data at speed. So that's a little bit of a commercial for us. We're really easy to do that with and really powerful, but it's also true. Nothing's happening. Things don't happen if you can't see it. If you're not recording it, you can't see it.
No, exactly. That makes perfect sense. Is it also a case of focusing on sort of the outcomes the business outcomes, because we talk a lot about that you're looking to achieve as well. So
I think,
no,
I don't want to be cavalier, but that's even another level. Just start seeing what your things are really doing. Just start seeing the real world the way it is. Then you can figure out what the outcomes are. Because there's no doubt if you can see the world really is, you're going to make better decisions based on that. So my fundamental. The other thing I would say in terms of advice, if you're listening to this and you're running industrial concern, is look for hiring people who are developer oriented, not operation, or you have to have both. But usually most industrial convergers don't have enough of the developer-oriented, IT-oriented, building things, collecting data, understanding plumbing of data, and all that sort of stuff. Look for those kinds of people. I think they'll be elemental to the next generation of industrial concern.
No, excellent. No, really good advice out there. And to your point before, Evan, nothing wrong with plugging or even a subtle plug of products. This is perfectly acceptable on this podcast. But if people wanted to find out more about Influx and what you're doing, where would you suggest people go to?
Yeah, a couple of things. Obviously, www.influxdata.com. It's the place where we have all of our images and all the information in our university and our tutorials and our blogs and all the normal stuff you'd expect. I also say, go to our site or go to GitHub and download the open source. If you're a developer at all technical, it's really relatively easy to build something around it. Really easy. And people do everything from monitor the temperature of their pools and their house and their energy use to running, huge infrastructures across large industrial concerns. It's that kind of fundamental capability that scales like that.
Yeah, exactly. Yeah, that's good. Yeah, that's quite a broad use case as well. So that's quite. You must see all sorts of and speak to all sorts of different people every day with so many different use cases.
It's it's a broad set of use cases. The other thing I'd say I neglected is there's a free cloud. There's a free trial in the cloud. Free forever. You can build a simple system in the cloud for yourself. You don't even have to download it. That's on our website.
Excellent. So we'll definitely share the links to that in the show notes as well. But yeah, I think besides that, it's been a really fantastic chat. Evan, thank you for sharing your your perspective on things. I'm sure everyone out there listening will have learned a lot. And like I said, we'll put all the links to the website and things so people can set up free trials or reach out to you for more questions. But I think for today, unless there's anything else you wanted to add, Evan, thank you again for your time. And thank you, everyone, for listening. And we'll see you on the next episode.
Thank you, Niall. It was a pleasure. Thank you.
Please like and subscribe on all major podcast channels and find out more about Senseye Predictive Maintenance at Siemens.com.